our final lecture on the last part of section 5.5, 5.5B. We're going to do a little review of integration by substitution. Now you do have an assignment that on the first part that you've already completed. There is an assignment now posted for you on section 5.5B, which is due next Monday. So you have a little bit of time to work on this. Let's take a look at this first problem as a review here. We're going to use this differential equation and the point shown on the graph to find an equation of our function. In other words, to find the antiderivative's exact value. So as you recall, we're looking for the integration. Now we're talking about, this is a review of indefinite integration, but the integration of 4x plus 9x squared divided by the quantity 3x cubed plus 1 to the 3/2 power. Remember, we have to always use the differential there. Now the first thing that we need to do is to consider what is the composite function, and substitution, there's always going to be a composite function to look at. The other thing to consider is that this is the integration of an indefinite integral of two functions. So I'm going to start by breaking this apart. So we have the indefinite integral of 4x dx plus the indefinite integral of 9x squared divided by 3x cubed plus 1, all that to the 3/2 power dx. Now the first integration is pretty straightforward. That will just be 4x to the second power divided by 2. Don't forget, with indefinites, we have to use the constant here. The second one isn't quite as easy because we do have a composite function. To get started though, I'm going to write this as 3x cubed plus 1 to the negative 3/2 power, and then I'm going to put 9x squared, in fact I'm going to put that in parentheses, 9x squared dx then together. Now as you recall, again the first integration is done. The second one is the one we need to work on. We have to be able to recognize, is there a composite function? And of course there is. The inside function is 3x cubed plus 1. So we're going to let u equal 3x cubed plus 1, and then take the derivative with respect to x of that, and we would have our 9x squared plus 0. We're going to make a substitution, so we need to have a term that has the differential x in there. So we'll multiply both sides by that differential x, 9x squared dx, and we now can substitute that whole term with just du. So our substitution number 1 is going to look like this then. The first part we're just going to bring down. So we'll just bring that down, make it 2x squared plus c, kind of tuck that off to the side. So the first substitution is only on the second integral. So that is the same thing as the indefinite integral of, remember u represents the inside function, so we have u to the negative 3/2, and 9x squared dx has the same value as du. So now we can work this problem, again bringing down the first antiderivative because it is done. The second one though is going to be, I'm going to write this out just as a reminder that we are adding 1 to the exponent and then dividing by the new exponent, plus c. So we'll just do a little more work on this, 2x squared plus c plus, and then here we're going to have u to the negative 1/2 power, which makes our denominator negative 1/2, plus c. And we'll keep working our algebra here for this next step. And we're going to have dividing by a fraction is, of course, multiplying by its reciprocal. And we can then move this term here to our denominator to make a positive exponent plus c. Now, the original problem is in terms of x, so we need to go back and make sure that with our differential x that we have a antiderivative in terms of x. So we do our substitution number 2 here, and this is going to give us that our antiderivative is 2x squared plus c minus 2 divided by, now let's go back up, u represented 3x cubed plus 1, so we're going to come back down and put that here, 3x cubed plus 1 plus c. Now we could stop at this point. The other thing we probably want to do is recognize that if you have a constant and a constant, you have a constant. So we're going to just write that as 2x squared minus 2 divided by, let's see, I think I forgot that this is to the 1/2 power. So let's do this at this point, and let's write it as the square root of 3x cubed plus 1, and then we'll just have a constant. Now the problem could stop there, except that it says in the original problem, use the differential equation and the point shown. So this is the point we're looking at, the point shown on the graph, to find the equation of the function, which is, we're talking now about the antiderivatives function. So we have the point is 0, 2. So if we know that we have the point 0, 2, that then is going to tell us that f of 0 equals 2, which would then give us 2 times 0 squared minus 2 divided by the square root of 3 times 0 cubed plus 1 plus c. So what we're going for here, as you recall, is looking for the value of that constant. So we've got 2 equals, we've got a 0 here. So we have 0 minus 2 divided by the square root of 0 plus 1 plus c. Or in other words, we've got negative 2 divided by 1. So we have 2 equals negative 2 plus c, which tells us that c has a value of 4. So what is the equation of our antiderivative? Well, it's exactly what we have right up here. This is our antiderivative right up here. Except now we know what the value of c is. So we would have 2x squared minus 2 divided by the square root of 3x cubed plus 1 plus 4, and that then is our equation. Now recall, if this is our function, how do we check it? Well, if we take the derivative of this function, what should we get? Well, you can test it out and see, but what you should get then is this value right here. And you can test that and see if in fact that is what we get. Okay, well now let's go on definite integrals, because now we again have the upper and lower bounds. And to start this problem, I'm going to integrate from 0 to 2. I'm going to make this 4 plus x squared to the 1/3 power x dx. Now, as we did on the review problem, we're going to let u be the inside function, which in this case is 4 plus x squared. We're going to take the derivative of that, and that would be 2x, and we multiply by the differential. So du is 2x dx. If I look at this problem, I can see that I have x dx, but not 2x dx, so I'll multiply both sides by 1/2, and that will then give me x dx as what I need. Okay, let's do the first substitution. And to begin this, I'm going to leave the upper and lower bounds off just for a moment. We would then have u is 4 plus x squared, so that's u to the 1/3 power. X dx is the same thing as 1/2 du. So we would end up with 1/2 integration of u to the 1/3 power du. Let me talk just for a moment about those upper and lower bounds. The 0 and 2 are upper and lower bounds for the variable x. Since we have let u equal 4 times x squared, so we have u equals 4 plus x squared, when we let x equal 0, that means that u is equal to 4. So instead of, if we're in the variable u, the lower bound would be 4. If we are going to use the upper bound for x, that is that x equals 2, then u would be 4 plus 2 squared, or 8. And so if we're going to put any bounds on here, we would have to use 4 and 8 instead of 0 and 2. Again, 0 and 2 are what we use for the variable x. U is not the same thing as x. It's 4 plus the square of x, and so our bounds would change. Now, I'll come back to that in just a minute, but for now, if we're going to put bounds there, lower and upper bounds, we're going to have to change them. We can't use the exact same thing. Okay, if we continue on, we would integrate this, so we would have 1/2, and then we would have u to the 1/3 plus 1 would be the 4/3 power, and we would divide by 4/3. And we're going to integrate this from, in this case, 4 to 8. Now we know that if we divide by a fraction, it's the same thing as multiplying by the reciprocal. And so we would have 1/2 times 3/4 u to the 4/3 power, and we would be integrating that whole thing from 4 to 8. We can combine this to be 3/8, and we'll do that in the next step. Now, as a integration problem, we know we need to go through and put the upper bound in and then the lower bound, but before we do that, let's go back and do our substitution number 2, which is that in place of u, we're going to put in 4 plus x squared. So this problem becomes 3/8. Again, we'd have 1/2 times 3/8. 4 plus x squared to the 4/3 power, and we're going to integrate, because now we're back to the variable x, so we're going to integrate from 0 to 2. On the variable x, we integrate from 0 to 2. So let's talk just a moment about the need to make this replacement of 8 and 4 for the 0 and 2. Again, this is because we are now in variable u on this portion of it. And you see that when we make our second substitution, we're back in variable x. Is it necessary then to actually go through and put in different ones? And I'm going to allow you to not, as long as, let's just make it a and b here. So we'll just recognize that there are some upper and lower bounds, but we're not going to bother with this because we're not going to use those new ones for u. We're going to go right back to our variable x, and so their bounds would remain to be 0 to 2. Now keep in mind, we're going to use the antiderivative with the input value of 2, and then from that subtract the antiderivative with the input of 0. So with that in mind, we're going to have 3/8, 4 plus 4, I'll put it in as 2 squared so we can see where we get the 4, 2 squared to the 4/3 power, minus, I'm going to go through the same thing, but now replace the input with 0, minus 3/8 times the quantity, 4 plus 0 squared to the 4/3 power. We want to simplify our arithmetic